So this video is about factoring and common factoring. So we're going to go through some common techniques, some common ways to go about factoring. So the motivation behind this is that we are well aware of how to expand two factors. So if we get something like this, x minus 2, x plus 1, for example, we use the FOIL method or any method that's taught in school to expand. So we expand the first term to every single term on the second one, and then we do the same with the second term. So what we're trying to do is work backwards so that we can find what these factors are. So let's go ahead and see what these questions are telling me to do. So it's saying factor 8x squared plus 2x. So the first thing we should be doing is common factoring, meaning what's the common term in every single term. So if I have 8x squared plus 2x, I have an x in both the terms, and I have a 2 factor in both the terms. So what I'm going to do is take out the x from both the terms and a 2 from both the terms. So I'm essentially dividing both terms by 2x then. So this leaves me with 2x, and then 8x squared divided by 2x gives me 4x, and 2x over 2x is just 1. So I'm left with 2x and 4x plus 1. So what I'm doing is looking for any common terms that I can factor out from every single term in my equation. So let's move ahead to the next question. So we have 6xy plus y squared. So I'm going to go ahead and look at if I have a number, a coefficient that's common in both the terms. I have 6 and 1, so there's no common coefficient or common factor from both the terms, so I can't really factor anything out. But I'm going to try and see if I can factor out a variable. So I have x in one term, not in the other term, so I can't factor it out. But I have a y in both the terms. So what I'm going to do is try and factor out the y. So I'm going to divide both terms by y, which leads me to 6x plus y on the inside. We're familiar with how to expand these kind of expressions. What we're doing now is working backwards to see how we can get the initial expression. So let's move on to the next one, which seems a little more complicated. So we have 2x cubed yz plus 8x squared y minus 24x5y. So once again, we have to look at, is there any common factor that I can take out from every single term? So I should look at the coefficients first. So I have 2, 8, and 24, which should be evident that 2 is a factor of all the terms. So I can take out a 2 from every single term. And then I'm going to look at, is there an x in every single term? And there's x cubed, x squared, and x5. So the biggest term I can take out from all of these is going to be x squared. And then is there a y in every single term? Yes, so I can take out a y from every single term as well. And then there's a z here. There's only a z in one of the terms, so I can't really factor it out. So let's go ahead and factor out these terms from my expression. So I'm factoring out 2x squared and y. So I'm left with x, z, because I'm getting rid of 2 over here. I'm getting rid of my y, and I'm getting rid of my 2. And over here, I'm left with 4. I'm left with no x's there, and I'm left with no y's there, so I have plus 4. Over here, I'm left with 12, and I'm left with x to the power 3, and that's all I have. So it's going to be a minus 12x cubed. So what I've done is essentially look at what are the common terms in every single term in my expression. Right, so what are some factors? So I look at the coefficients, and I saw 2, 8, and 24. My common factor is 2, so I can factor out 2 from every single term. Then I looked at how many x's can I take out? What's the least amount of x's that's in every single term? And it's x squared. So I factored out an x squared from every single term. Then I looked at the y's. There's a y in every single term, so I took out a y as well. So I'm left with 2x squared y and xz plus 4 minus 12x cubed.